All right, integrated 2. Going to try this again. It's my second attempt. I've been trying to upload videos for 4 hours. It's frustrating. One way or another. Doing complex numbers, also known as imaginary numbers. Complex numbers solve the problem of having a parabola that does not cross the x-axis. Where do these solutions come from? There has to be 2 of them, and they don't cross the x-axis, so they're not real answers, but they are imaginary answers. They also solve the problem of taking the square root of a negative number. You've been told for many, many years that you cannot do that. I'm here to tell you today that you can. And it's a pretty simple thing. It's simply plus or minus 2 with this italicized I. You can imagine the I stands for imaginary. I'm going to show you how this works in just a second. So there's a form of complex numbers, and the form is this: A plus BI. And they're called complex numbers because they contain both an imaginary part and a real part. And when you combine them together, you end up with a complex number. For your information, this is the form that we typically like seeing it. We like the real number first, plus or minus there, and then the imaginary number second. Now for a little background info. The deal is, a long time ago, the imaginary numbers had to come into existence in order to make all the math work. So a long time ago, they defined imaginary numbers, and they defined it as I. But they went a little further. They started with saying I equals the square root of negative 1. When I say they, I mean mathematicians of the past. But if I equals negative 1, then that would mean that I squared is going to equal negative 1. I said negative 1, I meant is if I equals the square root of negative 1, I squared equals negative 1. That's because if I squared this, it would nullify that square root sign and just give you that. But then they went a little further and said I to the third is going to equal the negative square root of negative 1. And then they went even further still and said I to the fourth is going to equal positive 1. This is by definition. By definition. We will be using only these 2 here, okay? These 2 over here have uses in higher mathematics, but we're going to concentrate on I and I squared. I equals this, I squared equals negative 1. So today's goals are these 3. We're going to try to simplify imaginary numbers, we're going to add and subtract them, and then we're going to multiply them. Let's start with simplifying. When we're simplifying, some of them are pretty easy and some of them aren't. This little square root of negative 9, I'm going to remind you that with square roots we can separate them, meaning I can make that the same as the square root of negative 1 times the square root of 9. Now the square root of negative 1, we actually just defined that, and we said that this is I like that. Times, and then the square root of 9, you know, is plus or minus 3, but that's not how we write it. We write it like this: plus or minus 3i. Now, the question might occur to you, do you need to do all this junk here? You don't. If you just go straight from here to there and give me that answer, I am satisfied. But there's other examples. That's a pretty easy one. But this explains how we take the square root. It's this portion right here. The fact that I equals the square root of negative 1, that's the key. What's the square root of negative 81? In the past, you couldn't do it. Now you can. Simply plus or minus 9i. And don't forget, that does mean positive 9i and negative 9i. But what if we get into something that's just a little bit more complicated? Like, how about number 3, the square root of negative 8? Now, since 8 is not a perfect square, we need to split it up and write it in simplest radical form. Here's what I know. I know that the square root of negative 8 would be the same as the square root of negative 4 times the square root of 2, and that's because 2 times negative 4 is negative 8. But this one I know. That's easy. That's plus or minus 2i. Do I know the square root of 2? I don't, and that's how I'd leave it, just like that. There's my answer. Something key right here is the fact that this I right here, that I is where it should be. You really don't like having it back here because you can't tell if it's under a square root sign or not. So instead of putting it there, put it in between. That's the perfect spot. What about something like this? 2 times the square root of negative 48. Well, again, this square root of negative 48 could be like this, the square root of negative 16 times the square root of 3. I know what that is. That's plus or minus the square root, or not square root, 4i times the square root of 3. And now, can I multiply these? The answer is yes. So this would be plus or minus 8i radical 3. That would be my answer. Notice the I is right there. So just follow this line right here, from here to here, and then eventually it gets combined. Last one for simplifying. What if it's just simply the square root of negative 7? You can't take the square root of negative 7. It's not a perfect square, and I can't break it down. But here's the way I think about it. The answer is just this, plus or minus I radical 7. And the way I think about it is that this I right there, that I right there, just takes the negative out. It's just like, hey, if it's a negative, let's take that I out, and now it's positive. All right, the next topic, our second goal, is adding and subtracting complex numbers. And here's what I want you to think. Think combining like terms, where you treat I like a variable. If you think about it that way, this is going to be real easy. Let me show you some examples. Here's a good example. I have 2 binomials. Look at that I want you to think of that as a variable, and I see it's a plus sign. We're just going to think combining like terms. Clearly, this 2 is a like term with the 1, and then that leaves this one, that 3i, to combine with the 4i. These are like variables. Those are like terms. These are like terms. There's a plus sign in the middle. This should be relatively easy. Let's take a look at it. 2 plus 1, simple, that's 3. What about negative 3i plus 4i? Isn't that just plus 1i? There's a good answer. Do I need the 1 right there? Well, not necessarily, but if you like it there, leave it. That one was an easy one, but this one should be easy too, actually. It's just a minus sign. That's the only thing. But you can see we have like terms there. We have like terms there. Let's distribute that minus sign. And when I do, the parentheses can leave. These parentheses only exist to keep that out. So once I put it in there, well, then they can disappear. That's going to be plus I. And now what kind of like terms do I have? Well, I got the 7 and the 2 right there. I got these right here. Simply combine. Pretty simple. 7 plus 2 is 9. 5i plus 1i is 6i. Notice it is in the form a plus bi. I have the real number first and the imaginary second. That is perfect. Okay, well, how about multiplying? Here's our third goal today. I want you to treat I like it's a variable. And then I want you to remember that I squared equals negative 1. We're going to need this fact in just a second. This isn't super complicated. Just going to do a few examples, and I'm hoping that you'll get the gist of it. All right, here's example 1 for multiplying. As you can see, this is a distributive property type of problem. So I'm just going to distribute here and here. But one thing you need to know is, yes, I can multiply these. This is 3i times 5. That's just going to be 15i. This is 3i minus 2i. Well, 3 minus 2 is negative 6. But what's I times I? If you treat it like a variable, that's I squared. But then you got to remember that one thing that I asked you to remember, which was I squared equals negative 1. And if I squared equals negative 1, that means I need to replace this I squared with a negative 1 like this. Watch, I have that 15i minus 6, but then wait, I'm not going to write I squared. I'm going to write negative 1. And I got a negative 6 and a negative 1. You know that's positive 6, so this goes like this. And I'm going to put that in front, 6 plus 15i. So yes, I switched the order of that because I want the real number first and the imaginary number second. But this is the key. When you see an I squared, feel free to replace it with -1. Multiplying those made that positive. Let's do another example. All right, what's going to happen here? Well, what's going to happen here is you can see we have two binomials, and we're just going to do FOIL like we've done plenty of times. 4 times 1 is 4, and then 4 times that -3 is a -12i, treating it like a variable. Do the inner, that's plus 2i like this. Do the last, that's -6i squared. Wait a minute, dude. Did you just hear me say I squared? Boom. What does I squared equal? -1. So I'm going to have to replace that, but I've got some combining like terms that needs to happen too. Look, I've got 4, -12i plus 2i is a -10i minus 6, but instead of that I squared, I'm going to put a -1. And what does that do? Well, it's another 6. I didn't expect that, but this is -10i. -6 times -1 is +1. And now look, I need to combine these. I've got 4 plus 1, that's 5 minus 10i. So as you can see, I had to combine terms twice. I had to do it once right here like that, and then another time right here with this number here and that one there. And don't forget, what does I squared equal? Like that. Last example. I'm just showing this to you to remind you not to kill puppies. That 2 right there, you know you got to expand it. So let's make it like this. 8 minus 4i and then 8 minus 4i. I'm going to do this quickly. I'm going to do FOIL. That's going to be 64. That's going to be -32i. This is going to be -32i. This is going to be positive 16i squared. Did you hear me say I squared? Because you know what that means. That is a -1. I know that for sure. Do I have the room? I do barely. I'm going to combine some like terms. This is going to be 64. Oh, look, minus 64i. That's a positive 16, but that's a -1, which makes that -16. Combine this and that. And what is that? 48 minus 64i. Bam. There's my answer. Notice once again, the real number is in front and the imaginary number is behind. All right, so those are my examples and my notes for now. Don't forget, take a picture of your work, highlight the answers, turn it into the classroom on this assignment, all right? Oh, this has been a struggle today. I've been working at it for hours and hours and hours. I'm sorry this is so late. I promise I'll get better at it. Hope you're doing well. Take care. Peace.